Hey, so yeah, I think I'll do one more video on volume. I wasn't sure. The energy is getting very late. But just a quick recap, we're doing shapes, writing down in English, the strategy of what we're going to do, and then we write down the equations which we are given, apart from a cylinder or basic prism, substitute in, and watch the rounding at the end. So those were adding shapes, get a pair of, those were adding shapes apart from this one, which was a working back the way. But these ones are takeaways, so I thought I would just do these as well as a little takeaway. They're slightly harder than the other ones, and you will find that with the volume. This is one of those questions where they can make it a wee bit trickier, I think, than some of the other topics. So, again, as usual, everything that's in here, if you read it, is actually in the diagram. So all you have to do is remember to round to the end. What we'll do here is we'll take the volume of the cone, and I'm going to take that away. I take away from that the volume of half a sphere. That's what's going on, isn't it? This glass cone has got a little copper sphere at the bottom, half a sphere, and to get the volume inside the glass bit, I'm taking away half the sphere. So if you were to look at it kind of side on, the shape of this is doing something like that. It's like that shape you get at the bottom of a wine bottle or a glass bottle. So volume of a cone, we have got a third pi r squared h. So that I'm going to take away half of a sphere, is 4/3 pi r cubed. Watch the cubed, you're also used to writing pi r squared, be careful of that. And let's just check our radii. Now this is quite an interesting one. Usually the radii is shared, but you see here, there's a little gap around the side, so the radii, this isn't just as wide as the cone. So the cone has got a radius of 3, so a third pi, sort of 3 f 4, times 4 squared, the height is 15. Over here, the radius is going to be a half of 7.4, so 3.567 times 3.7 cubed. So that's quite interesting. Usually those are the same, but that's just because you look on the side, this isn't just the full width of it. So actually, if I was really exaggerating that drawing, it's doing something like this, isn't it? If I really exaggerate it. And if we work that out, calculators at the ready, and get used to, I always say this, you should have a calculator, get used to using it, because if you get a different calculator, it can be quite tricky. So on the calculator we get 145.24, and I want to round that to two significant places. I'm going to be rounding up, so it'll be 150. Don't put the point zeros after it, don't need them, you only need this zero for place value. So yeah, 5 marks. It's a good 5 marks, to be fair. You just got to take your time, get your strategy, don't make any mistakes in your calculator, and just make sure you're using all the information there. So maybe on the side, you might have decided to write, r is equal to 0.7, r is equal to 4. You could sketch it up, but just make sure you're not making any silly mistake. This one. Okay, so I just want the shaded area. I want this bit in here. So what I'm doing is this whole cone, take away a small cone. So it's the volume of the big cone, take away the volume of the small cone. It's using one equation, so it's going to be a third pi r squared h, take away a third pi r squared h. So a third pi. Now the radius of the big cone is going to be half of this. So that 15, 16, so times by 16 squared, and the height of that would be 24. That would give me the full volume of this big bit here. And to that, I'm going to take away the volume of this small cone, this little bit in here. So I'm looking at using this radius, 18 divided by 2 for 9, and the height of 30.5. Do that on your calculator, and we get 5288.871, and that's the two significant figures. So there's 1 and there's 2. That's going to become 5300 centimeters cubed. So this, it looks a wee bit trickier, this one. I can see why you might look, what do I do here? But really, big cone, take away small cone, makes sense. The big mistake people make here is if we take this as the radius, then the height would just be height to here, but that would. So usually you're adding or taking away shapes when you look at this. So think, is it an add, is it a take away? When you see the dotted lines here, you see this. It's not a dotted line, but you see that it's a bit missing. If there's something missing out of it, thinking right, it's going to be a takeaway, isn't it? And the very last one I'll do is this. So we've got a sphere. The outside's got chocolate, caramel. Good. Sorry, it's caramel in the middle, coating a caramel sphere with chocolate in there. So that's lovely. All the data is shown there. Yep, so the volume. So the volume of the chocolate is this outside bit. So again, what you're thinking is the outside bit. If I do the whole sphere and then I take away this inside, this internal sphere, that's going to give it the chocolate. So you're just saying it's the volume of the big sphere, take away the small sphere. And we've got the whole sphere, and then I take away this bit in the middle. I'll just highlight it. If I take away this bit in here, obviously then I'm just left with the chocolate bit. So don't overcomplicate it. So the big sphere, so it's all 4/3 pi r cubed. Take away 4/3 pi r cubed. The radius of the big sphere, let's see, is 24 for the diameter, so it'll be 12 for the radius, and the small sphere, now we've got working out required here. So we've got 24, I know this is 3 and this is 3. The diameter of the small sphere, this is 24 take away 6, it's going to be 18. So then the radius will be 9. It's going to be 4/3 pi 9 cubed. And we'll just do that on our calculators. And I get very easy to make a mistake at those points, so just really take your time. Sometimes you can even do this sum, write it down, take away this sum, that's totally fine. Doing it as one big sum can be quite easy to make a mistake, so watch out for that. So I'm getting this, and it's going to be in millimeters. And 3 significant figures, 1, 2, 3. Do I have to round up? No, I don't. Find your place. Look next door. If it's 5 or greater, add one more. It isn't. There we go. Nice one. So again, this becomes 0. We don't need zeros here because they are not significant. And I think that's probably all we want to do for this. So think of your strategies, write your equations, substitute it in. That's the big point to make. Your equations are given up here. Don't be that person that writes it down wrong. Take your time, look at the equation, double check it. Just take your time. If you're doing the non-calculator paper, remember your decimals. There's only a mark for it, so get as far as you can and just leave it and come back to it. If you're worried about it, the working here can be huge for some people. A lot of time, so don't waste time on that. But if you are multiplying your decimals, remember, just add the decimals in at the end. We talked about that. But think of your strategy. Write down in English what you're doing. Half a sphere plus a cylinder. And just take your time. Don't mix up diameters and radii. Working back is probably the most challenging one. That's effectively a change the subject question rather than a volume question. And again, here, this was in the non-calculator paper. You should have really got down to at least here anyway. Yeah. So hope that was helpful. And feel free to practice the last few questions. Again, look, big cone, take away small cone. The only one I see here is a wee bit trickier is the area of the triangle for this one. That's quite an interesting one. You know what? I'll very quickly just have a look at that. It's the only one I've seen that's a wee bit trickier. So it's looking at the volume of the box. So in this case, it's giving you a triangle. You should know the area of a triangle, a half AB sine C. So you're saying it's a half times 10 times 10. And how would you possibly get that angle in the middle? Well, the angle of the whole thing is 360. So the angle is going to be 360 divided by 5. So that's going to be 7 5s, carry on, 72 degrees times sine of 72. So let's get that on our calculator. Fantastic. So let's say I have one triangle, and then I'll say it's 5 times 47.55 is going to be the area of the face. And then I'll take that and times that by 5 again to get the depth, and that's going to give me to do 1902.11. So a bit short on time, but yeah, hope that's helpful. Sort of different area of a triangle.